Divisibility rules. Today, our learning intentions are to know the meaning of the terms divisible, divisor, dividend, quotient, and remainder, to understand that divisibility rules can be used to determine if a number is divisible by another number without actually having to do the division, and to be able to test for divisibility. You will know you are successful when you can easily determine if a number is divisible by 2, 3, 4, 5, 6, 8, 9, and 10. And you have bonus success if you can also know the 7, 11, and 12 rule. Let's learn about divisibility rules. Divisibility in everyday life. So whenever a barcode is scanned, an algorithm first checks whether or not the barcode is valid. The digits are combined using a formula, then a divisibility rule is applied to test whether or not it is a genuine barcode. It is really useful to know whether or not a large number can be exactly divided by smaller numbers. And while we could go through and do the division for every single number, that's very tedious and can take a long time. So it's really useful for us to know these short, quick little ways to figure out whether or not a number can be divided into smaller parts. These divisibility tests can determine whether or not the number is divisible by the chosen divisor. Our key ideas. So a number is said to be divisible by another number if there's no remainder after the division has occurred. If the divisor divides into the dividend exactly, then the divisor is said to be a factor. That's a lot of math words. Let's check we know those. Dividend. Okay, the dividend is the starting number, what we have at the start, the total, the amount that we have. The divisor is the number that's going to be doing the dividing, okay? The number of groups we're breaking it up into. The quotient is the number of times that divisor can go into the dividend. Basically, it's the answer. And we know remainder. It's the number left over. You may be wondering why it's really important for us to know our divisibility rules. Well, they can help us to list the factors of larger numbers, which come into play in so many different areas. Whenever we do simplifying ratios, fractions, any of those things, we're going to use our factors. We also use factors for a range of different things like comparing prices, exchanging money, calculating travel times. So divisibility can be really useful for us to just know. We're going to start with the easy ones. Is something divisible by 1? Well, all numbers are divisible by 1. We can take any number and put it into a group of 1. So this one's super easy. Although it's not actually very useful most of the time, because if we take a number and divide it by 1, it's going to end up as the same number. But let's see, are these numbers divisible by 1? Well, as long as they're a number, they are divisible by 1. So 7, 14, 17, and 193, all divisible by 1. Divisible by 2. You may already know this one. Basically, a number is divisible by 2 if it's even, which is if the last digit is even or 0. Remember, our even numbers are 0, 2, 4, 6, and 8. Let's test these numbers. 128, that ends in 8, even. It's divisible by 2. 129, that ends in a 9, not an even number, not divisible by 2. 27, ends in a 7, not divisible by 2. 74, ends in a 4, that is divisible. So is the last digit 0 or an even number? Divisible by 5. This is probably another easy one that you know pretty well. When we count in 5s, a number always ends in a 0 or a 5. So if the last digit is 0 or 5, it's divisible by 5. 175, that ends in 5, it is divisible. 809, that ends in a 9, not divisible. 65 ends in a 5, it is. And 193, not divisible. So is the last digit a 0 or a 5? Divisible by 10, the last of our super easy divisibility rules. You know, when we count in 10s, it always ends in 0. So if the last digit is 0, it's divisible by 10. If the last digit is 0, it's divisible by 10. So 220 ends in 0, yes. 221, no. 164, no. 75, nope. So if the last digit ends in 0, it's divisible by 10. So those first 4 divisibility rules were super easy, and we can just look at the number and know instantly whether or not it's divisible. But it is still super important that we know our basic multiplication and division facts, because that's going to help us for all the rest of the rules. For the rest of the rules, we still need to know our basic division facts, but it kind of helps us to take large numbers and figure out how to make them smaller to see if it works. Let's give it a go. Divisible by 3. If the sum of the digits is divisible by 3. So what we can do here is add the digits together. So for 39, 3 plus 9 equals 12. Does 3 go into 12? Yes. So that means 39 is divisible by 12. 381, that's 3 plus 8 is 11, plus 1 is 12. So 3 goes into 12, so 3 must go into 381. 217, 2 plus 1 is 3, plus 7 is 10. 3 does not go into 10, so 3 does not go into 217. You can actually repeat this rule multiple times. So 99,996, when I add 9999 and 6, I actually get 42. I can do that again. What's 4 plus 2? That's 6. Does 3 go into 6? Yes. So 3 goes into 99,996. So if the sum of the digits is divisible by 3, then it's divisible by 3. Divisible by 4. So we still need to know our 4 times tables for this, but if the last 2 digits are divisible by 4, then the number is divisible by 4. So 1,312. We just look at the last 2. Does 4 go into 12? Yes. So this number is divisible by 4. 7,019. Does 4 go into 19? No. So 4 does not go into this number. Now I have 28,373,862,132. Is it divisible by 4? Well, I just look at the last 2 numbers. Does 4 go into 32? Yes, it does, 8 times. So that number is divisible by 4. So if the last 2 digits are divisible by 4, then the whole number is divisible by 4. Divisible by 6. The 6th rule is a little bit different. If a number is divisible by 2 and 3, then it's divisible by 6. That's because 2 times 3 equals 6. So basically, is the number even, and does the digits add up to a number divisible by 3? So, first of all, 114, is it even? Yes, so it's divisible by 2. Is it divisible by 3? 1 plus 1 is 2, plus 4 is 6. 6 goes into 3, so it's divisible by both, which means it's divisible by 6. 308, it is even, so it's divisible by 2. 3 plus 8 is 11. That's not divisible by 3, which means it is not divisible by 6. 216, that's an even number. It's divisible by 2. 2 plus 1 is 3, plus 6 is 9. 3 does go into 9, which means this number is divisible by 6. 81, not an even number, which means it is not going to be divisible by 6. So if a number is divisible by both 2 and 3, that means it's going to be divisible by 6. Divisible by 8. Now this one's going to require the most amount of little bit of math, because if the last 3 digits are divisible by 8, then it's divisible by 8. So 816. Now you might not know straight away if 816 is divisible by 8, but you can check in 2 ways. First way is just to do a normal division. 8 goes into 8 one time, 8 goes into 1 no times, 8 goes into 16 2 times. So that is divisible by 8 because there's no remainder. Another way to do it is to half the number 3 times. So 816 split in half is 408. That's 1 time. 408 halved is 204. That's the 2nd time. 204 in half is 102. And if that's a whole number, then it's divisible by 8. Let's try the next number. The last 3 digits is 302. So if I do the straight normal multiplication, 8 goes into 30 3 times with 6 left over. 8 goes into 62 5 times with a remainder, which means it's not divisible by 8. If I try my halving method, 302 in half is 151. That's 1 time. 150 in half is 75 and a half, and that's got a remainder, not divisible by 8. So if the last 3 digits are divisible by 8, then it's divisible by 8. Divisible by 9. Much like the 3 rule, if we add up the digits and that is divisible by 9, then the whole number is divisible by 9. So 2 plus 7 is 9. That's divisible by 9. So 27 is. 64. 6 plus 4 is 10, and that is not divisible by 9. 1 plus 6 is 7, plus 2 is 9, plus 9 is 18. 18 is divisible by 9, so that number is divisible by 9. 2013, 2 plus 1 is 3, plus 3 is 6. 6 is not divisible by 9, so 2013 is not divisible by 9. So if the sum of the digits is divisible by 9, then it is divisible by 9. When most people teach divisibility, they don't teach you these next numbers, but I don't think they're too hard, so I think you can do it. Divisible by 12. If the number is divisible by both 3 and 4, then it's divisible by 12. Same as the 6 rule, because 4 times 3 equals 12. So a number is divisible by 12 if the digits added together are divisible by 3 and the last two digits are divisible by 4. 6 plus 4 is 10, plus 8 is 18. That's divisible by 3. Then we've got 48. 48 is divisible by 4 12 times. So that's 3 and 4, which means 648 is divisible by 12. 524. 5 plus 2 is 7, plus 4 is 11. That is not divisible by 3, which means it will not be divisible by 12. So if a number is divisible by 3 and 4, then it is divisible by 12. Divisible by 7. Okay, no one is teaching you this rule, but it's actually my favorite because I think it's kind of fun. So you double the last digit and then subtract it from whatever's left over. And if that number is divisible by 7, then it's divisible by 7. Let me show you. 672. What is double 2? That's 4. And we have 67 left. 67 take away 4 is 63. Is 63 divisible by 7? Yes, 9 times. So this number is divisible by 7. 105. The last digit, double it. 5 times 2 is 10. What do we have left? We have 10. 10 take 10 is 0. Is 0 divisible by 7? Well, technically, yes. So this is divisible by 7. 905. What is double 5? That's 10. What do we have left? 90. 90 take 10 is 80. Is 80 divisible by 7? No. So divisible by 7, take the last digit, double it. Take it away from the number that you have left over. Is that number divisible by 7? Then yes, it's divisible by 7. Divisible by 11. Now I had never seen an 11 rule before, but I think this one is heaps of fun. So you add and subtract digits in alternating order until you get an answer, and then you check, is that divisible by 11? So let me show you. What's plus 1? So 1, take away 3, negative 2, plus 6, that's 4, take away 4, that's 0. Is 0 divisible by 11? Technically, yes. So 11 goes into that number. Let's do the next one. What's 9? Plus 9, take away 1, that's 8, plus 3, that's 11. Is 11 divided by 11? Yes. So 11 can fit into that number. This one, plus 3, take away 7, that's negative 4, plus 2, negative 2, take away 9, that's negative 11. Can that be divided by 11? Yep. So 11 can fit into that one. Positive 9, take away 8, that's 1, plus 7, that's 8. Can 11 go into 8? No. So 11 can't go into that number. I think that one's pretty cool. So in my hunting to try find an 11 rule, I also found another one that I think is pretty cool. So you subtract the last digit from the number made by the previous digits. So this is kind of like the 7 rule, but you don't double it. So let me show you. I got 136 take 4, which gives me 132. Now I take that and I take away the last digit again. 13 take away 2. That gives me 11. Does 11 fit into 11? Yes. All right, 913. 91 take 3 is 88. Does 11 go into 88? Yep. 372 take away 9 is 363. 36 take away 3 equals 33. 11 goes into 33. 98 take 7 is 91. 11 does not go into 91. Can't go into 987. I hope now you can easily determine if a number is divisible by 2, 3, 4, 5, 6, 8, 9, or 10, and maybe even sometimes figure out if it's divisible by 7, 11, and 12 without tricky rules.